Okay, today we're going to talk about exponential functions. A function of the form y is equal to b to the x, where b cannot be equal to 1, is called an exponential function. These functions have distinctive graphs and are widely used to describe high rates of growth and or decay. When something is growing very rapidly, we say that it is growing exponentially. When something is declining very rapidly, we're saying it is decaying exponentially. All right. So that's where these functions are mostly, what they are mostly associated with. All right. So I'm going to leave that y is equal to b to the x, where b cannot be equal to 1. It's called an exponential function. All right. Now, what's the root word for exponential? Exponent. So that means it's raised to a certain power. All right. Once again, I want to say these graphs and functions are widely used to describe high rates of growth and or decay. That means basically the opposite of growth. All right. So now, let me give you an example of what we mean. The first thing I want to do is talk about the growth right here, and why we say something is rising exponentially. All right. What we're used to working with algebraic functions. So just say I have y is equal to 3x. Three times 0 is 0. 3 times 1 is 1. 3 times 2 is 6. 3 times 3 is 9. And 3 times 4 is 12. Okay? This is algebraic, which means it's a linear function. All right. Now let's go over here, and we have this is linear, this is exponential. 3 to the x power, and let's put these same numbers in. Now, one of the first things you have to know, this is 3 to the 0 power, which is 1. I'm going to put a star by that. We're going to talk about that. Anything to the 0 multiplied by 0 is 0. Anything raised to the 0 power is 1. All right. 3 to the first power, which is 3 times 3 to the first power is 3. 3 to the second power, 3 times 3 is 9. 3 to the third power is 27. And 3 to the fourth power is 81. So right here we can see how 3 times 4 is 12. 3 to the fourth power is 81. So you can see the different rate in which the exponential function is growing. Let's add 1 to it. 3 times 5 is 15. You can see it's just increasing by 3. 3 to the fifth power is 243. So that's how we can see that different level of growth right here. All right. Now, yeah, of course it would be very, very difficult to graph on such a small scale, but just to give us a glimpse of it, your linear function, I know it's not coincided, but it would be pretty much a steady increase. It's increasing. Uh-oh. Yeah, I made a mistake right there. This is 3. Sorry. Yeah, it's increasing by 3 every single time. Make that. Teacher makes mistakes too. Over here, it is increasing very rapidly. So at 3 times 1 is 3. And 3 to the first power is 3. So they're both right here. But then you can start seeing where this graph just what takes off and increases. That's why we say something, we use it as a figure of speech, that something is rising exponentially.